Hello students, in this video we will discuss about neural networks in data mining. Okay, so what are the neural networks? Okay, we call neural networks an artificial neural network, and it is a mathematical model, or we can say it as a computational model which is designed based on biological neural networks. Okay, so this artificial neural networks will work same as a biological uh, neural networks. So we will compare this neural networks in data mining which works similar or matching to a biological neural network. Okay, so in many cases an artificial neural network or neural networks is an adaptive system. Okay, why we are saying it an adaptive system means we can make changes to the model or to the network system or structure based on external or internal information that flows through the network through the network during the learning phase or during the learning model, or we can say it is during the learning algorithm. So that's why we call neural networks as adaptive system. Okay, why we are calling neural networks as an adaptive system means we can make changes to the structure based on the internal, that means which we based on the internal structure of the network or based on the external information which we are giving to the network through the network, that may be changed while we are in the learning phase or learning model of a system. Already we know what is learning model means. Based on the existing data, by analyzing that data, we will model a system, or we will design a structure is called learning model or learning phase or learning algorithm. Okay, that's why it is an adaptive system. Okay, so a neural network, this is a structure of a neural network. Okay, a neural network is composed of processing elements. Okay, this is also basic structure of a neural network. So a neural network composed of processing elements called perceptron. Okay, so we call this as a processing element or perceptron. So what is this perceptron or processing element? This is a node. We call this perceptron or processing element. We will represent this also as a node or neuron in a network. Okay, we'll say it as a node. So this processing element receives input. Okay, if you see this structure, what are all these are called processing elements, where it will receive input. Okay, and do some processing. Here it will receive some input, do some processing, wi into xi, this is some processing it will perform, and it will gives or it will delivers an output. Okay, a single output. Here in neural networks, the structure or a network will gives a binary output, that is either 1 or 0. Okay, so that's why we are saying only two values, yes or no. Okay, only two values, either yes or no. That's why we are saying it will delivers in perceptron or a processing element will delivers a single output, yes or no, 0 or 1, or any one output. Okay, that is called a processing element. Okay, so in this network, this is a processing element where we call it as a perceptron, where it is represented as a node in a network which receives input okay, which receives input and performs processing and delivers a single output. That is called a perceptron. Here it is called a perceptron or node. Okay. So here what we say, in this network, the output is the final result. That is either yes or no, or 1 or 0. Okay. So the output of one processing element, okay, the output of this processing element or perceptron will be input for the other node or other perceptron in the network. See, if you see this, okay, we can have multiple layers also. Okay, now this is a perceptron, which is, this is input layer and this is output layer, and we call this as a hidden layer, where this will perform the processing. Okay, now the output, what this will do, it receives input, performs some processing and delivers some output, final result. That final result may be input for the other node in the network. So whatever the input we are receiving here, this input may be the output of some other processing element or some other node in the network. Okay, so this is the actual structure of a neural network. Okay, so each neural network is composed of collection of nodes. Each neural network is composed of collection of nodes or perceptrons grouped in layers. This is the collection of nodes. This complete network is collection of nodes which is grouped in layers. So how many layers it has? 3 layers. That is input layer. This is called input layer, which receives input, and second one is hidden layer, and next we have this layer is called output layer. These are the 3 layers. Okay, so this hidden layer is also called intermediate layer. Okay, so in a network we can have many number of, we can have any number of nodes, or any number of nodes which are placed in the hidden layer. In this example, in this structure I am showing only one node, but here a hidden layer can have any number of nodes and which are organized in different layer, in where each node is receives a different input from the input layer and process and results output. That means it delivers output to the output node, which is also called a node, where it receives the output, and this output may be input for the other node in the network structure. Okay, so what this hidden layer will do, so this hidden layer will receive input, different input from the input layer, and which will transform that input in the hidden, in the processing element, which is in a way which will transform the data in a way which will help to process by this processing element. That is performed by the hidden layer. It has to transform the received input in a way which is helpful for the processing element to do some processing and delivers the, or do some operations and delivers the output. Okay, that is the hidden layer. Then what is the output layer? This is the output layer which receives input from the hidden layer. Okay, and display a binary output, either 1 or 0, or we can say true or false. We can say yes or no. Only 2 binary output. Okay, it will delivers only one output at a time, either yes or no, true or false, 1 or 0. Okay, so here what we will do, when we release some output, if an output is released, we have to check whether a given output is reaching the user value or predicting the correct value or not. We have to check. So to check this, in order to predict whether a delivered the given output is predicting the class accordingly to the model or not. So what we have to do here, we have to compare the given output with some threshold value. Okay, so what is this threshold value? Threshold value means it is a value where we are giving a constant value or some where we are giving a value according to our program or according to our data set. Based on that, we may change. Sometimes we may put it as a constant, the threshold value. Okay, suppose if we have some n records in a data set, based on that n records we will decide a value. Sometimes we may change that value, or for all the records we put that value as a constant. If the given output is reaching is greater than threshold value, then we can say the result is true. If it is less than threshold value, then we can say it is false. How we will say? Based on 1 and 0, true or false. We have to decide. If it is greater than threshold given value, then we can say it as true, otherwise false. Okay, this is the basic structure of a neural network. Okay, where a neural network, which we will represent as a biological neural network, where a processing element called a neuron, node or perceptron, which receive inputs and transform the given input in order to process the data by the processing element, and gives an output where the given output has to be checked to check whether it is reaching the whether it is predicting the value or not by comparing with the threshold value. The threshold value is given by the based on the data in the given data set. Okay, this is about how and what is the structure of a neural network.